This is lesson 9.3, and we'll call this A in trigonometry. And we're going to call it A because it looks like this is a pretty long section. So anyway, gosh, as far as logarithms are concerned, if you've already had college algebra, you've already studied logarithms in depth, and you'll notice that this is kind of a summary of logarithms. If you have not had college algebra, then this is just kind of getting your feet wet with logarithms, and in college algebra we'll go into a lot more detail. But anyway, we have two different types of logarithms. One is called a common logarithm, and one is called a natural logarithm. It's called a natural logarithm because it's mostly used in the natural sciences, biology, physical science, those kind of things. But anyway, we're going to start out with common logarithms. Common logarithms all have a base of 10. Now up to this point we've been doing like, let's go ahead and put an actual one up here that works. So we had something like that, which written in exponential form would be 5 squared equals 25. Okay, so that has a base of 5. Most of the time in math and sciences we're going to be using it with a logarithm with a base 10. Now when we have a base 10, it's kind of like having 1x or the square root. You don't put, like in the square root of 4, we don't put the index of 2 in there because it's assumed. It's the same way with logarithm. If there is nothing there, then it's an assumed 10. Okay? So what this particular one is saying is, what exponent can I put on 10 that will give me 5? So anyway, that is what a common logarithm is. A natural logarithm that we kind of got into a little bit is an irrational number e, if you remember the letter e. And we'll get into that natural logarithm later. Let's stick with the log logarithms right now. And let's look at, they just kind of jump around a little bit here. Let's look at the first bit of story problem information that they give us, and that is dealing with pHs. Alright, so pH is the hydronium ion, which is H3O. Alright, the thing that you'll notice here is it's very close to H2O. And by adding a third hydrogen ion to where it's H3O, we get a hydronium ion. Okay, so this is what we're going to be looking at right now. And we have a formula that says pH equals negative log of the hydronium ion. And when you take the hydronium ion and we take the negative log in it, notice the base is a base of 10. Alright, so this part here you really don't have to understand. Okay, so if you haven't had that yet in chemistry, that's okay. Alright, so this right here, pH, is the measure of the acidity or the alkalinity of a solution. So you have from 1 to 14, water, pure water, is H2O, and it has a pH of 7. And if we have a number that's less than 7, they're called acids. And if they are greater than 7, they're called bases or alkalines. So anyway, you don't have to know all of that stuff, but just to kind of give you a little bit of an idea of what we're getting into. So let's look at example 1. And let's see. Find the pH of a solution with the hydronium ion equals 2.5 times 10 to the minus 4. So let's put the formula up here. Negative log of the hydronium, and that plus that's in that exponent position. You'll learn what that is later. It has to do with protons and electrons. But anyway, right now it doesn't really matter. Just be able to substitute. Alright, so Find the pH of a solution with a hydronium ion as 2.5. So instead of writing the hydronium ion, which we have here, we're going to put 2.5 times 10 to the minus 4 in its place. And we're trying to find the pH. Okay, so we're solving that, and that'll give us the pH. Now notice we have a times sign. So if you remember, when we have a times sign like that, we can do the log of 2.5 plus the log of 10 to the minus 4. Okay, notice I put the log out there because this log is distributed on this one and this one. Okay, you can't just take the minus and put it on one of them. So we pull it outside of the parenthesis. We take our calculator and we find the log of 2.5. And we take our calculator and we find the log of base 10 of 10 to the negative 4th power. Now if you look at this right here, let's look at what we've got. We have 10 to what power equals 10 to the minus 4. So our bases are the same, which means our exponents are the same. So this whole thing right here turns into just negative 4. Alright, another way to look at this is a log with the base and answer the same is going to equal 1. Now if you look back on, let me find the page here, bottom of page 407, it says log base A of A equals 1. So if these two are the same, they are the same as 1. So that means we replace this here with 1, and therefore we have just negative 4 as our answer. So let's see, negative log 2.5 plus, and that's going to be negative 4. Log of 2.5 is going to be, actually, here, let's make a little bit of a change here. Forget this, I'm sorry. We still have our negative outside our parentheses, so I don't want to make any major changes. So log of 2.5 is 0.3979, and then this is going to be a net minus 4 because I've got a plus negative 4 there. So now I'm going to subtract that and get a negative, and then a negative and a negative would give me my positive 3.6. And that pH is an estimate there, it's not a guarantee. Okay, let's do part B. Find the hydronium ion concentration of a solution with a pH of 7.1. So now we're doing a little bit different. Instead of finding the pH, we're finding the hydronium ion concentration. So that's going to be negative log of H3O, like that. Alright, so now we're searching for that. Alright, so when we do that, what we're going to do here is we are going to get rid of that negative. So remember from old-time algebra, if you have an equation and you want to change the sign on any part of that equation, that's fine, but you have to change the sign of every other part. So negative x plus 3 equals 12. If I want to change that to a positive, I just do this, and it changes it to a positive. It's the same with what we're doing here with logarithms. So I don't want that log negative, so I'm going to change it to positive, but I've got to change that to a negative. And that gives me an H3O positive there, which makes life a little bit easier not having that negative on there. Okay, so let's change this into exponential form. So we are going to write this as, this is a log of base 10, so it's going to be the 10 to the negative 7.1 power equals this here. So that's just like me having, say, for instance, like that. I would take 10 to that power, set it equal to that there. And that would be switching it to logarithmic form, or exponential form. So, didn't do anything weird, it's just that H3O thing kind of throws you off a little bit, I think. Alright, so, at this point, I can take my calculator and put 10 to the negative 7.1, and let's see, I'm going to try this. I haven't done this before. So okay, it didn't work. I was trying to make a video of me using the calculator, but I can't make it work. So we'll use this pretend one here. Alright, so if we're going to do 10 to the negative 7.1, you push the 10, 1, 0, and then I've got a y to the x power. So the 10 we put in there as the y. So you put 10, click that, and now we're ready for the exponent. Then we type in 7.1, click this button here for the minus sign, and that'll give me negative 7.1 as the exponent. Then I hit equal. And then you should get 7.9 times 10 to the negative 8 for an answer. Alright, so let's see if I can get rid of this calculator now. Alright, get ready for the next video. 9.3b as in boy.